All right, so we know the derivative is a limit. We know that it is a limit that expresses the slope of a tangent line. We know that the notation for that derivative is commonly f prime, but that common notation is just one of many notations. You could also express the derivative as dy over dx, sort of indicative of the slope that you've got there, like a change in y over change in x. And if you sort of rearrange the terms of that, you could express it as d over dx times y. We also have examples, and you know that if you ran through the computation, cumbersome as it may be, using the limit, you could come up with the derivative for x squared, for square root x, or for 1 over x. Now the goal for this video is to determine a way to find the derivative of a function which is itself a sum of two functions. So here's the idea, like when could a function be a sum of two functions? I mean, what if you had a function, let's say q of x, which was x squared plus square root x? So here's sort of the bubble of thought associated with this idea, which is to say, here's a function, a perfectly valid function, right? You could plug in something for x and get out something back in return. You could plug in 9 for x and get out 81 plus 3. You could plug in 16 for x and get out 16 squared plus 4. You could plug in 4 for x and get out 16 plus 2. In fact, you could plug in anything for x, as long as that x was greater than or equal to 0, so that the square root would make sense, this function would make sense. So this is a perfectly valid input-output device. This is a perfectly valid function. And this perfectly valid function you could graph, and when you're looking at its graph, you could zoom in at a particular point, and you could see the tangent line. That tangent line would have a slope. So the goal here is to try to find a way for this function to determine the slope of its tangent line. And rather than running this function through the limit technicalities, which can be very cumbersome, what I want to try to get us to do is to work with the technicalities in general to allow us to use the knowledge of this derivative that we already have to be able to compute the derivative without having to go through the technicalities, to essentially shortcut the technicalities by going through them in general. So let's try to address this issue of how do you take the derivative of a function which is itself a sum of two functions? And well, to do that, let's go through the limit to see how to do this. So here is the evidence behind the idea. And well, let's take the derivative for a function such as this. So to take the derivative dy over dx is the limit as h approaches 0 of the original function with x plus h plugged in. So in this case, that would be f of x plus h plus g of x plus h. All we're doing here is just taking the function that we have here, which is a sum of two functions, and plugging in x plus h for x. What do you then do? You then subtract the function plugging in x, right? You subtract the function plugging in x, so here, that's just the function f of x plus g of x. And then what do? You divide that by h. So here is our situation. We want to sort of work through this. So here's what I'm going to do. I'm going to rearrange these terms because you can see that we've got an f of x plus h subtracting an f of x. We've also got a g of x plus h subtracting a g of x. I'm going to rearrange the terms here slightly so that the f of x plus h minus the f of x is written adjacent, and the g of x plus h, which is being added, is written adjacent to the g of x, which is being subtracted. So we've taken the positive f of x plus h and the negative f of x, and the positive g of x plus h and the negative g of x, and written as so. And note, while the g of x may not be completely adjacent to the subtraction sign as it is sort of articulated here on the board, the negative is going to be distributed to the g of x, so that g of x indeed is negative. And now, to take this expression and sort of make sense of it, we're going to break this fraction apart, essentially using an idea that you know, which is to say that, like, I don't know, 4 plus 1 over 7, right? This is just, well, you know this is 5 sevenths, but this is just 4 sevenths plus 1 seventh. the long story short is, if you're adding two numbers over a common denominator, you could express each of those numbers over the common denominator to see the addition broken down into its sort of elemental chunks. And we're going to do the same thing here, because you can break this sum into its chunks. Note each has a common denominator of h, right? And you've got these two terms in brackets which are being added together. So if we express this out, we get f of x plus h minus f of x over the h plus g of x plus h minus g of x over h. This is merely taking the two terms that are being added together, each over h, and writing them as individual terms over h. Nothing more complicated than 4 plus 1 over 7 is the same as 4 sevenths plus 1 seventh. But now, whenever you see this written as so, you have a limit as h approaches 0 of this expression plus that expression. And what is that? Well, you know what the limit as h approaches 0 of f of x plus h minus f of x over h is. That is just f prime. And you also know what the limit as h approaches 0 of g of x plus h minus g of x over h is. That is just g prime. And what you can see has happened through the course of taking our derivative here is that the derivative of the sum of our functions is just the derivative of the first bit plus the derivative of the second bit. And man, that works about as well as you could imagine it, which is to say that whenever you are taking the derivative of a sum, you just take the derivative of each term and add them together. So in the case of like our x squared plus square root x, you can very quickly compute the derivative under this observation. Our original function is x squared plus square root x, so our derivative is going to be 2x plus 1 over 2 square root x. Why? Because the derivative of x squared is 2x. Remember that from our example. The derivative of square root x is 1 over 2 square root x. That was also from our example. So using the knowledge that we had before from actually going through all the tedious detail, we don't have to go through the tedious detail anymore. And in fact then, for any function, which is a sum of two functions, you can compute its derivative simply by taking the derivative of each function and adding them together.